to another daily challenge. Today we have product of the last k numbers. It says design an algorithm that accepts a stream of integers and retrieves the product of the last k integers in the stream, which is k is an argument, by the way. Yeah. So it says implement product of numbers class, which is this, where it initializes the object with an empty stream, and then there is add that adds a number to a stream, get product, and it takes k as an argument. Return the product of the last k numbers in the current list. Yeah, you can assume that always the current list has at least k numbers, so that's guaranteed. Basically, right, it says down here, the follow-up. Can you implement with get product, both get product and add in O of 1 time instead of O of k? We're not going to do the O of k today. We're not here for the O of k. This solution is actually O of 1. So, yeah, it's pretty non-convenient, but it works. And that's what I'm here to explain today. So basically, we have a stream of numbers. We keep gaining numbers, right? And for example, like, let's take this example. You add 3, you add 0, you add 2, you add 5, you add 4. It wants to get product of the last 2 only, right? So, bada bing, bada boom, 20. And then last 3 if it wants, last 4 if it wants, whatever. And then, yeah, so that's basically the question, right? Okay, so one easy way to actually do this in O of 1 time is to actually have a prefix of multiplications. So basically, every time you add, so basically the prefix here 3, the last prefix here is 0 because multiplied by 0, right? Obviously gonna still be 0, right? And it keeps going like this, right, basically. So if you keep this prefix till the end, let's say there is no 0 here. Like, let's say this was a 1. So basically, if you have this prefix, and then it wants the last k, right? So basically, you have this prefix, and you have this prefix. You can easily just divide them together and get this. So basically, all of this divided by this part gives you this part. What is the catch, you tell me? Tell me what's the catch. The catch is sometimes there's zeros. And zeros just ruin it completely, because anything multiplied by 0 is going to be 0. So basically, this is the perfect example for this, where this is the first time in Leetcode where they actually give an example that actually covers everything. So, for example, this is 0, right? Multiplying it just ruins the whole concept, right? But you'd think so. However, there's a way we could actually go around this. We can also not just keep the prefixes of multiplication, we can also keep the 0 count we've seen and act accordingly. Meaning, let's assume every 0 in this array is a 1, right? So if we encounter a 0, we're actually going to add it as a 1, just to make this work, just to make this concept work. But we're going to increment a 0 counter. And then, let's say if it wants the last k prefix, which is case 3, so once this, right? I'm going to check, right, for this prefix, what's the count of zeros, right? It's 1. And then for this prefix, what's the count of zeros? It's 1. If they're the same, that means I've never encountered a 0 here, which means I can divide them together peacefully and assume this is a 1, divide them together peacefully and get this, right? What if the 0 count is never going to be less. It's going to be either equal or more. If it's more, then it's a guaranteed 0. Then I'm going to return 0 anyways, because then 100% this k prefix is going to be 0, right? And that's basically how you go around this. It's non-intuitive, but it works in a way where you just have to trust your gut and see where it takes you. So basically, we start off having this multiplication prefix array, and then in add, right, I'm going to check. If number is 0, I'm just going to assume it's 1. Else it's going to be 0, right? So this is just a 0 flag where it's set to 1 if the number is 0. Otherwise, it's just going to be 0. And then number, I'm going to change number to 1 if it's 0, right? I'm going to change it to 1 if it's 0. But I took care to count it in by this variable, right? And then I'm going to check if there exists an array I think this could be written in a better way, but I really care. If it exists, I'm going to append to it. What am I going to append? I'm going to take the last prefix, and ideally you take the last prefix, multiply it by the current number, and then move around, right? So basically, I take the last prefix, which is this, because it's going to be a tuple. So basically, every entry is this is going to be a tuple. Tuple consists of what? The prefix and the number of zero counts. So basically, I'm going to if there's a number in the prefix, I'm going to take the last one, multiply it by nums as a first entry, and then there is zero plus increment the zero count, basically, whether this is a zero or not. Increment the zero count. Otherwise, it's just going to instantiate a new, like, I'm just going to add the first entry to the array, which is like the number the same as it is, and zero, whether this is equal to 0 or 1. Like, if number, basically meaning number is always going to be, it's never going to be 0, because we done that, we changed it to 1. And is 0 is going to be either 0 or 1, depending on whether this number is actually like underlyingly a 0, right? And then and the interesting part is, in get product, right? What happens? First of all, I check, does k equal, do you want me to get, so sometimes it asks for k, where k is the whole length of the array, basically. So if that's the case, I'm just going to return the last value, basically. But I need to check as well, because we never set zeros in our prefix. We never have zeros. So we need to check, is the last value, is the whole prefix of the array, does it have any zeros, right? If it doesn't have any zeros, return it, because that means it doesn't have any zeros, so the prefix is always going to be correct. Otherwise, just return a 0, because you're multiplying everything by 0 anyways, right? So this is just to handle this case, where if the k is always going to be equal to the length of the prefix, right? Otherwise, I'm going to take the last prefix and the last 0 count of that prefix, the whole prefix array. Oh, sorry. Like, basically speaking, something like this, right? And then it wants the multiplication prefix, and then I'm going to take minus k minus 1. Basically meaning, let's say it wants to get product of 2. So basically it wants the product of these. The product of these is going to be equal all of this, right, divided by all of this. And then k is 2, so I basically need to stand here to get the prefix of all of this, and then divide them together. So that's what I'm trying to do here. So I get basically both these prefixes, and then I'm going to check if the 0 count is the same. So basically the 0 count is the same, meaning the prefix is not 0, because that 0 is encountered here, not here. So if the 0 count is the same, I'm going to divide them successfully together. Otherwise, that means there's a 0 here somewhere, so I return 0, and this is an O of 1 solution. Yeah, so that's been it, guys, for this one. Thank you, and see you in the next one.